Okay, so for this one, the radius is 7.2. So to figure out the volume, you use the plain old volume formula, 4/3 pi r cubed. And this one says round your answers to the nearest tenth. So we're not going to have pi in there at all. So you can go 4 times pi times 7.2 cubed divided by 3, all in one calculator step, and get an answer of, we'll all say it at the same time, 1,563.5. Do you agree?
Yeah.
Yes, that's what you guys got too? Okay. And that is centimeters cubed because it is volume. And we also have to find the surface area. What's the formula for the surface area of a sphere? 4 pi r squared. Good, because it's area, so it's going to be squared. So that's 4 pi times 7.2 squared. So you go 4 times pi times 7.2 squared, rounded to the nearest tenth, and you get 651.6. 0.4. Wow, 2/10 of a cubic centimeter off there. Did you use like 3.14 instead of the pi button? Oh, okay, whatever, that's fine. 651.4 cubic centimeters. Okay, so no worries there, right? Oh yeah, I'm sorry. Thank you. Centimeters squared. Because it's area. Thanks, Greg. All right, then number 2, things get a little bit dicier because now we have a hemisphere and a cone. Oh, it's even worse than I thought. And they tell you that this whole height is 7. Okay? So to figure out the volume, we need to do the volume of the hemisphere, and we need to do the volume of the cone. Okay? So what's the formula for the volume of the hemisphere? 2/3 pi r cubed. So that's going to be 2/3 times pi times 4 cubed. And so again, since they want this in decimal form, you could just go 2 times pi times 4 cubed divided by 3. And then say what the answer is. Yeah.
Down 2.
What? I know, but it's hot in here.
They're only up 2, and the guy from Bonaventure's got stuffed by Ram on a wide open dunk, pretty much. It's like baseline dunk, and he's got hacked by Ram.
Okay, what you get for the volume of the hemisphere? 134.04. So we're going to go with 134.0. Thanks. Abby? Gail Young? Abby Gail Young? Okay, what's the volume of the cone? What's the formula for the volume of a cone? 1/3 the area of the base, which is a circle. So it's 1/3 pi r squared times the height.
No way.
So 1/3 times pi times, what's the radius of the cone? 4, so times 4 squared, times, now they didn't tell us the height of just the cone. It would be 3, very nice. Right, because yeah, the radius of this would also be the height of the hemisphere. So this distance right here is going to be 4, so that leaves 3 for the height of the cone. Okay? So actually that makes things easy because now the 3's cancel. So you can just go pi times 4 squared.
Tied it up.
50.3. And that is cubic centimeters. And what do you do with those two answers? Add them together. So you get 184.3 cubic centimeters. or the volume of that whole thing. Okay? Okay, but now we also have to do the surface area. Ugh. Who made this worksheet?
Today's restroom.
Yeah. So for the surface area, we have to add the surface area of the hemisphere onto the surface area of just the side of the cone. Okay? What's the formula for the surface area of a sphere? 4 pi r squared. So if we want the surface area of a hemisphere, it would be 2 pi r squared. And since the radius is 4, that's going to be 2 times pi times 16, which is what? Say again? 32 pi, but we want it as a decimal, so that's 100.5. And that, Greg will tell you, is square centimeters. Right, so what's our formula that we have for the surface area of a cone? We haven't done that for a long time. Pi times the radius times r plus the slant height. So now we actually have two things that we have to do. One is we have to figure out what the slant height of this cone is, because they don't tell us what the side of it is, but that's not too bad. I got a right triangle right here. So this is 3, this is 4, so the slant height must be 5. Okay? So the surface area of the entire cone would be pi times 4 times, what's the radius plus the slant height? 9. So that would come out to be 36 pi. But as Greg pointed out, that would include the circular base. And in this case right here, the circular base is covered up by the hemisphere sitting on top of it. So we actually have to subtract that. So what is the area of that circular base? No, because the hemisphere formula didn't take that into account, so we're good there. 16 pi.
Well, don't you divide by pi?
Right, so 20 times pi is 62.8. Okay, and so if you want the surface area of both of those, what do I do with these two numbers? Add them together, so I get 163.3 square centimeters. Okay, one more. And then we'll have a practice test on Monday and test on Tuesday. And then on Tuesday, I'll collect all of these worksheets that I've given you this week before your test. Okay? We're on number 3. We're going to do number 3, and then we're going to call it a week.
Come on. Florida State's up 3.
Time?
4:30.
Getting close, huh?
It was their first lead of the game, though.
Okay, so last one. Once again, to do the volume, I have to find the volume of the hemisphere and add on to that the volume of the cylinder. Okay? Volume of a hemi, yeah? Hemi-cuda. Yeah. Barracuda with a hemi engine in it. What? Okay. All right, hold on. Stay with me. Stay with me. What's the formula for the volume of a hemisphere? 2/3 pi r cubed, because it's volume. Okay. So again, you can just do that straight on your calculator. 2 times pi times 5 cubed divided by 3. happened?
I don't know.
I didn't hear.
I just gone.
At the exact same time.
I want to do that.
Two what? Okay, and that's cubic centimeters. Then the volume of a cylinder, we've done that before also, pi r squared h. So that's going to be pi times 5 squared times 8. So you can just do that straight on your calculator. Is it r cubed right here? No, it's r squared because this times this gives you a cube eventually. Okay? So it's r squared because it's the area of the circular base times the height. Okay? So 25 times pi times 8 is... No, I don't think so.
Yeah, it is.
It is? Okay.
628.3.
Okay. Sorry. Trying to do math in my head, didn't work out. All right, add those together and you get a grand total of 890.1 cubic centimeters.
Just kidding.
No, because we're talking about volume, not surface area. Okay, so we don't have to subtract anything. We will have to do some subtraction when we figure out the surface area, but we will do that on Monday. Okay?